Hi, I wanted to go over a few applications of linear functions from section 10. I've pulled a few problems from Top Hat, and this first one is one of the quick check problems within the reading. And it says, according to the National Center for Education Statistics, there were 13.2 million undergraduate students enrolled in degree-granting post-secondary institutions in fall 2000. In fall 2014, the enrollment was 17.3 million students. Assuming this relationship grows linearly, write a linear function that models the undergraduate enrollment in post-secondary institutions X years after 2000. So we're given two data points from this information. We know that there were initially 13.2 million students in the fall of 2000, and in 2014, there were 17.3 million. So we can write that as two ordered pairs. We were told that X represents the years after 2000. So the year 2000 is really 0 years after the year 2000. So one of our ordered pairs will be 0, 13.2. The other one comes from 2014, which is 14 years after 2000. There were 17.3 million students. So now that we have two ordered pairs, we can use the slope formula. Remember, that's y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1 to calculate the slope between these two ordered pairs. Our y values are 17.3 minus 13.2, and that's divided by 14 minus 0. And if we round that to two decimal places, we get 0.29. And so the linear function that models this enrollment is, well, it's y equals mx plus b. Remember, where m is your slope and b is the initial value or the y-intercept. And so our slope we just learned is 0.29 x plus the initial value we were actually told, which is 13.2. A very similar problem is from the actual exercise set. It's question 20. It was in 1997, the cost for a 30-second Super Bowl ad was $1.085 million. In 2017, the cost for a 30-second ad was $5 million. Assuming that the cost grows linearly, write a function that models the cost of a 30-second ad in millions, where X is the number of years after 1997. So again, we were told two pieces of information. 1997, the cost was 1.085 million. Well, the year we're going to put 0 because 1997 is 0 years after 1997. The year 2017 is 20 years after 1997, and the cost of the ad there was $5 million. So to find the slope, we're going to do the change in y divided by the change in x. So that's 5 minus 1.085 divided by 20 minus 0. And the slope then is 0.19575. So our linear function, again, we know our slope and we know an initial value. So our y equals mx plus b is 0.19575 x plus b, which is 1.085. Now, to use this function, we want to find what is the projected cost of the ad in the year 2020. And so we have to figure out, well, how many years is 2020 after 1997? And that is 23 years. So to answer this part, we want to find f of 23. So we're going to substitute into the function we just found the 0.19575 times x, which is 23, plus 1.085. And we get $5.58725 million. Another problem is question 21, which is the cost to rent a truck from a local home improvement store is $19 for the first 75 minutes plus 33 cents for each minute over 75 minutes. Write a function that models a cost to rent a truck where x is the number of minutes over 75 minutes. Then use the model to determine the cost to rent a truck for 2 hours. And we're not to round. So the initial cost to rent the truck is this initial $19, right? And so we're going to have our $19 for the initial value. And the cost per minute over that is 33 cents. So we're going to say that the cost actually increases by 33 cents for each minute over 75 minutes. So a linear function that models the cost to rent the truck for x minutes over 75 minutes is, remember our slope, which is 0.33x, plus our initial value, which is plus 19. Now understand in this model that x is a number of minutes over 75 minutes. So when we need to find the cost to rent the truck for 2 hours, well, 2 hours is 2 times 60, which is 120 minutes, right? So we need to figure out how many minutes over the 75 will we be using the truck. So 120 minus 75. And what is that, 45? Yes, so to find the cost to rent the truck for 2 hours, we actually will evaluate the function at 45. So we have 0.33 times 45 plus 19. And we get 33.85. And then one last problem from this section is in the year 2000, the average monthly price for basic cable was $29.99. So understand here is a pairing of quantities, right? In 2016, the average monthly price for the same basic cable TV was $59.75. We want to write a linear function that models the cost for X years after 2000, and then use that function to determine the cost of basic cable television in the year 2020. And we're only going to enter the final answer below, but we have some work to do to get that answer. So we know that we have a pairing. We know that in the year 2000, which is the year 0, the average cost was $29.99. In the year 2016, which is 16 years after 2000, the average cost was $59.75. So to write a linear function requires us to find the slope. So the change in y, which is 59.75 minus 29.99, divided by the change in x, which is 16 minus 0, we would get 1.86. So remember, we're looking for the linear function of the form y equals mx plus b, where slope we know, and actually the b value we know. And again, this is only known because we have a coordinate with x of 0. So the y value of that coordinate is the value of b. So we would have y is equal to 1.86 x plus 29.99. So keep in mind, this means that it was $29.99, and the average cost is increased by $1.86 per year after the year 2000. So to figure out what is the cost of the basic cable TV in the year 2020, well, 2020 is how many years after 2000? It is 20 years. And so if we evaluate the function at 20, we will get the answer to this problem. So we need to do 1.86 times 20 plus 29.99, and that is $67.19. So if you have any questions on these, please don't hesitate to contact me. I hope this gives some further insight into how to work these problems. Thank you. Bye-bye.